All right, so I think now's a good time to kind of pause and just talk about defining the direction of current flow. I haven't talked about that, not at all really up to this point. I just kind of just have been defining the current in the direction that we already know that it's flowing. And so in a circuit, like one of the more basic ones that we saw, let's say I have a 5-volt battery and I have a resistor right here. And so I know that in this circuit I have 5 volts. I'll just put ground here just to make it simple. 5 volts there and 0 volts here. Okay, I've talked about how I know that current will flow from higher potential to lower potential. So the current in this circuit will be flowing in this direction, and then it'll go around in this loop, right? I drew it that way. I've also drawn it as a loop. But I want to clarify something, okay? So if I were to find the current, let's just say that this is 1K for sake of example. If I wanted to find the current here, I would say 5 volts minus 0 volts divided by 1K. My V over R gives me my I. In this case would be 5 milliamps, okay? However, what this equation assumes is that I'm taking the plus side of the current flow direction and subtracting it from the minus side, right? That's what I'm doing. I'm taking the plus side and I'm subtracting the minus side, okay? So it's not always so obvious what direction the current is actually flowing, okay? In a circuit like this, it is obvious because I know that my voltage here is 5 volts, and I know that my voltage here is 0 volts. But we're going to get into some much more complicated circuits where the voltage source, it's not always clear. There's not always a direct, connection between the voltage source and the resistor like there is in this circuit. And so what I want to make clear is that it's not important the way that I define this current, right? The way that I draw this arrow and this plus and minus are not important. All that is important is that I keep this convention here. As long as I show that I'm assuming the current is flowing this way, and when I do that, I write the plus on the end of the arrow and the minus on the point of the arrow, everything will be okay, okay? And so let me just give an example. Instead, let's say I have some circuit, and I've got a bunch of stuff going on over here. I'll just draw it as a box. I don't really know what's going on over here. And then somewhere in my circuit, I'm interested in this resistor, and then I've got even more stuff going on over here, okay? So this is some black box that I don't know what's inside. This is some black box and I don't know what's inside. And so I have no idea what direction the current's going to be flowing in this resistor. It could either be flowing like this, or it could be flowing like this. It's really unclear to me based on what I've been given. But the point is that it doesn't matter. It really doesn't matter. If I define my current like this, then I just need to be sure that I put the plus side on the end of the arrow and the minus side on the point of the arrow. And then when I go ahead and I do KVL and everything else, I just keep straight that I'm assuming that I'm going to make a voltage drop from high side to low side, or higher potential to lower potential, when I go across this element, okay? And what's going to end up happening, so let's say that I did all this and I solve my KVL and I call this IX, and then I determine from a bunch of math that leads me to IX is equal to 1 milliamp. Okay, what that means is that I was correct about the direction of the current. It was going to be flowing from plus to minus, just like I drew it, the downward direction. But what happens instead if I get a value like negative 1 milliamps? Well, that's not wrong. All that means is that I was wrong about the direction that I defined the current. So in this direction, in the downward direction, I have minus 1 milliamps flowing, which simply means I have plus 1 milliamps flowing in the upward direction and not anything flowing in the downward direction. Hope that makes sense. So basically all I'm saying is you can define the currents in your circuit however you'd like. Let me go ahead and, I erased a lot there. So I put another resistor in here, let's say, and just to make the point clear, I'm going to call this IY. And again, I don't know that the current's flowing from left to right. I'm just assuming that that's the case. I draw my plus and my minus here. I go through a bunch of math and I determine IY is 2 milliamps. Then that means that I was correct and that my current is in fact flowing from left to right. But if I do all my math and instead I determine that IY is minus 2 milliamps, then all that means is that my current is actually flowing this way. Because I originally defined it like this and I got a negative answer. So all that means is that my current is actually flowing in the opposite direction. Okay, so hopefully that's clear. I think that's really important for the next video, which is KCL, or Kirchhoff's current law. And we're going to be using this idea that we can define the current any way we want, and it's going to make solving circuits a lot simpler. You don't need to keep track and try and determine just by inspection what direction. Sometimes you will be able to, like I said. In this circuit, you can very easily determine that the current's going to flow down through the resistor because the voltage is plus minus, and it's very obvious in this case. But a lot of times it won't be obvious, and so you just feel free to always define your current flow, plus, minus, arrow, and when you do your KVL or whatever we're going to be doing, it will all work out. And if it works out to be negative, then you just know that you got it wrong. You got the direction wrong, but that doesn't mean that this is wrong. It is correct. In this case, IX flowing downward with negative 1 milliamp is just the same thing as IX flowing upward with positive 1 milliamp. Okay? If there's any questions, obviously feel free to ask, but I hope that makes the point clear. And in the next video, I'm going to go ahead and introduce KCL.